class will run. So let's begin. Begin the class. Okay, here I introduced some model and some curve, and the important thing in the curve I mentioned, and for another part, the content here, I just hope the student just had an impressive about these things. It will be okay, and roughly, just roughly to know, and just if future, in the future, the other teacher, maybe in some place you find you need use this curve explain, and you can know where to find. That will be okay. Yes. So here's I hope to roughly know and have a impression about these things will be okay. Just to know why the curve behavior look like this, and the reason, and some relationship, the elastic modulus, the secant modulus, and the tangent modulus, the relationship will be okay. Yeah. Before I just the unaxial stress, right? Unaxial load applied to the concrete, but here, look at here. You will see for the concrete, right? For the plate, they under two direction load. What behavior, what stress strain curve of this specimens will look like here. Here I recommend the reference, right? Some material. If you're really interested about the concrete, you can to read this material, this reference. You will have a whole completely understand. And can you imagine? Can you imagine if the plate, under this two direction load, what behavior of it look like? Yeah. If this is the plate, if they under this direction load, they will be bigger, right? Be bigger. And if under this direction, the deformation will different. Yeah. If you here I found a video of the plane under the two direction load. What the behavior will look like. They just prepare like some this visual black curve lets you to know how this sample under this two direction load behavior. Right? Yeah, they give this compression. This direction is the tension. In the tension, it will be larger, and in compression, it will be smaller. There is the two direction tension, so he will like. This machine, we can understand the concrete under this two direction load will look like. Okay. And for here, the curve, the stress strain curve, we use these figures to describe it. To understand this axis, the name is the stress. Sigma 1 divide. And there is the sigma 2 divide FC. FC is the same, right? Here, we just can easily to understand just the sigma 1 and the sigma 2. Yeah, and we draw the curve. We draw the curve. Yeah, look at here. Look at here. In this part, this part is the positive, the value of the sigma 1 and the sigma 2, right? They're positive. So this curve is the disjoint line. That means under this curve, the sample broke. Yeah. So they draw this line. So in this part, they are positive, right? Positive means the sample, they under the positive direction load. They under the tension, right? And in this part means they under the compressive load, compression, right? They change the value negative. And in this part means in one direction, the spacemen under the tension, and in one direction they are compression. Yeah. So for this curve, what we can observe, that means if we increase the load, in this part is one direction is the tension, one direction is the compression, right? And in this part, that means if there are two directions increase the load, they are almost the same. That means the concrete can bear. It can bear. Yeah. Because the concrete comes to here, then the specimen destroyed, right? So that means the behavior of the concrete is under two direction load. If this two direction load is the same direction, the same value around these values, they will behavior more good, more good. Here's they're summarized that concrete compressor, the stress increase. If the tension, the stress is unchanged. For one direction in the tension, one direction in the compression. Yeah, the tensile compressive stress decrease. So for this figure is made clear. No, understand. Yeah, maybe it's hard to understand. But you know, right, to hear what I explained, maybe clear. If this is a sample, concrete sample plate that's used to test in the under the biaxial stress, right? For here is clear, and this curve is we obtained from what we do the test, right? And for this line, this line drawn here is the disjoint. That means when the values come to here, come to this value, come to like here is the 1.2. Yeah, this is 1.2. Come to here. That means the specimen is destroyed. Because we know this is the plate, the sample, right? Give the force. It will, because the concrete can resist the load. When it comes to a value, the failure load, the failure cracks will develop on the concrete samples. We just record the machine's value and draw the line here, draw the curve here, and now I just help you to read the curve, the leading curve here. It is hard.
Or maybe that's when you use the cubic test.
Cubic, not cubic, a plate sample. Look at here. The samples look like here. We give the force only in the edge. It's 4 edges, not give this direction. These samples we use here, and the concrete under the biaxial stress. Biaxial stress is 2 direction load applied to the concrete. Right?
Use reinforced concrete.
When it's used,
What if you use reinforced concrete?
when we use it, reinforced concrete, there's no reinforced, there's no steel bar, there's only the concrete. Because look at here, I just introduced the property, the material property of the concrete. Do not mention the steel bar here and reinforced concrete. Do not mention here. So we only talk about the concrete under one direction load, then under the biaxial stress load, and later we'll chill stress load. And what behavior, what phenomenon, what we can observe from the experiment, maybe boring or maybe, but this is the principle, just some basic principle for us to do the future design here. I hope you can realize that. Maybe hard to understand, but from the video, and also look at here. Yeah, look at here. They also give you the sample, give you the knowledge that you can realize this direction is the sigma 1, this is the sigma 2. And when we increase the load, come to a value, the specimen destroyed, and we record this value and draw the curve. The shape will look like this. And the meaning of the curve is, in this part means the specimen under 2 same direction load. And here is the same direction load. And in this part and this part means there one direction is the tension, one direction is compression applied to the specimen. And why this curve is important and interesting is that we find the concrete under the compression, the stress is really larger than the concrete under the same direction, the tension. Here is look at this curve. This is means the sigma 1 is equal to the sigma 2, right? Sigma 1, 2. That means this direction, the value, it grows at the same level, the same. Okay. Okay, so take a rest to read, to look at. For in this period, this one means the sigma 1 divided sigma 2, the value is a range at 0.7. This period is corresponding to this formula. And because this curve means the sigma 1 equal to sigma 2. Yeah. So during this period, the strength decrease with the increase of the stress ratio. Because these ratios, this point, that means the high strength, right? High strength. When we decrease the ratio, of course the strength is decreased. Because this point is the farthest with the original point, right? Other place is closer to the original point. So that means we decrease the ratio. Yeah, decrease the ratio, the strength also decreased. And with the strength change slowly, in this period, for concrete under this stage, the ratios in this range is good than the sigma 1 divided sigma 2. These ratios at this range. Yeah, here's what we conclude from this curve is that we know the concrete, the specimen under the biaxial stress, that compression, it can increase the concrete strength. That's why somewhere we can find this like tube, right? It's steel tube, and pour the concrete on there. They refine the concrete, because for the pier they under the load, right? They under this direction, but if we give the here, steel bar can refine the concrete. Can you imagine? Yeah. Oh, look at here. This is the tube. We pull the concrete. The concrete under the load, the compression, they will the transfer direction. The deformation will be larger, but it's restricted by the steel tube. Steel tube give the concrete this direction load, right? So that means we cut you cut this tube. Look at in this direction. This tube will give the transfer direction load to the concrete. This direction is the other load applied to the tube. So we use this method to improve the behavior of the concrete. Another is the strain curve. Before we talk about the stress curve, here is the strain curve. Also, we can collect the depth and draw the curve at here. For this curve is similar to the unaxial compression, but only the peak stress strain, this peak value is higher. The shape, because the curve, this one is we increased compression in two directions, right? Do you remember this curve? Before we in there, I introduced this only will give the specimen in one direction load. The transfer strain also will increase, right? And here is we give the two direction load and obtain the stress obtain the strains curve. Here list is the ratio, the stress ratio. And here stress ratios. Stress strain curves concrete under is higher, the shape in the sea, but the value is higher. And here is the failure patterns under the different biaxial stress ratio. This is the what we prefer is failure pattern that the ratio is equal to 1, right? Equal to 1. If someday you go you know the plate where it use, right? Because for building, right? For building the roof and there is the plate, right? Plate. And not the cube, okay? This is the color. Yeah, and for the buildings, there. This is great. Sometimes the crack will develop, right? We can use this failure pattern to explain if the crack developed. We find the crack developed. That means this direction the load, may be the near, the value is the close. This is we observed from the laboratory, but it can be used to explain in the reality. Yeah, in reality, some buildings, some find crack develop, right? Because the minor crack always exists in the concrete. The load just to let it enlarge. Okay, this is a part of the concrete and biaxial stress. here is a talk about the concrete under the tensile stress. One is the tensile and one is the compression. Yeah, okay. Here it may be complicated for you, but just can use this curve or this basic unit knowledge. Yeah, this unit knowledge can combine this thing together. They can explain some phenomena that we see it in our life. Before is the stress, right? Stress. This also in this axis is the stress, but we transform this axis at the shear. Do you know the shear? Shear is the shear force divide area. Shear force, yeah, to draw the curve. And from figures. In this part, that means no shear force. Shear force is the scissors to cut the samples, right? Here, shear force always appears shears curve on the samples. I use the Chinese maybe some student can listen. 就是剪应力 is the shear stress, right? 剪应力 always comes to the pair. They comes to a pair means 它总是成对的出现，成对的出现。Maybe tired? I need to sleep. Yeah, this is the triaxial stress. Okay, because look at their video. This video is to let you to see in the laboratory how we to carry to do the
by preparing your specimen in accordance
to do the triaxial test for the concrete. But here is the soil.
you will need to remove the split mold. In some cases, it can be useful to apply a small amount of non-corrosive silicone grease along the groove of the part of the split mold to help reduce resistance. We recommend the use of PTFE silicone grease. If the specimen is stuck, use a disc the same size diameter as your specimen to apply even pressure when pushing. Be careful not to damage the specimen in the process.
Completed.
Now you have removed the specimen, you can place it on the base pedestal of the triaxial cell. If you are running an effective stress test, it is important you ensure the triaxial base has been completely de-aired. If you have not de-aired your triaxial cell, please see the link highlighted in the video. The link is also available in the description below. Assuming the base has been de-aired, slide a saturated porous disc onto the base pedestal. It helps to have a film of water on the base to keep the stone saturated and avoid trapping any air as you slide the disc on. If you are not measuring pore water pressure or applying a back pressure, you may use plastic discs instead of porous
We
discs.
only two bars. Yeah, this is
Concealed by screwing the locking nuts
they
evenly.
put samples.
You may
on
wish
the
to apply a
base
small amount of
and
silicone
enter
grease on the
the
opening
pore
to help
water.
avoid leakage.
Okay, here.
Once it
There's the samples on the water. The surrounding waters, they will give the samples pressure, right? And this is the machine that we can do the test. And now is also the stress strain curve about recollect from the experiment. This experiment. This is the relationship we built from the chill. And this is the how we to do the test. This is the samples, the oil, and in the video is the water, right? Water counts. Yeah. The chill XU stress test. And from the chill XU stress and the biaxial stress curve, and when how to use it, because for the steel reinforced confined concrete, they use the steel to give the transfer direction force to the concrete, and to improve the strength of the reinforced concrete here. And here, it introduced the circle shape is better than the rectangular section. Because for the rectangular section, in this part, the refine effect do not work. Yeah, there is some factor affecting the confinement. Okay, then there is the basic mechanical property of the concrete, and today we finished, and later we will talk about the shrinkage and the creep. I will put this material to next week. And today class, I think our students may tired. But the important of this part is the curve, stress strain curve under one direction load. Yeah, I hope every student in the master. But for biaxial stress curve and the chill axial stress curve, and how to use these things, yeah, it's just a reference for you. You just rapidly know it and can explain. Yeah, that will be well. So okay. Yeah, okay, today's class is over. Thank you. Thank you very much.